Hello. Thank you for clicking on this video lesson on interval notation. This video does include the practice set with the practice set review, so if the timestamp is a little bit lengthy, that's why. Please like and subscribe if you find this lesson helpful to you. Ask a question, drop a comment below, and please check out the other videos that we have on the channel to help you with whatever it is you're looking at in your math class right now. Beginning with the question, what is interval notation? Well, interval notation is an alternative way to write inequalities on the number line. And I am going to link up here a refresher if you need to go over what inequalities are. So this would be your less than and your greater than and less than or equal to or greater than or equal to. Okay, and specifically on a number line, so not like on the coordinate plane, we're thinking about on the number line. So go ahead and click there if you need a refresher on that. Now, interval notation will cover open intervals. And again, that's where the refresher video might be helpful if you're like, what's an open interval? You use parentheses, and then this right here, now, depending on how old you are, for someone my age, that is called the pound sign. For younger people, this is a hashtag. And it is sometimes used as an abbreviation for number. Okay, so we have a number and then we have another number, and they are enclosed in parentheses. It looks like an ordered pair, but it's not an ordered pair like you would plot on the number line. It is an interval. Closed intervals will use a bracket instead of a parenthesis. And you can have one of each. So it is possible for you to see something like that, where you have an open interval on one end and a closed interval on another end. Now, if you didn't click on the refresher because you're like, I kind of remember that, open interval means that the endpoint is not included. So it goes down really, 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 really close to the 2. Okay, and it's typically done on the number line with an open circle, and it might get really, really close to the 2, so maybe 2.000001, but it doesn't include the 2. A closed interval is when the endpoint is included, and so on that one, it would be a 3, and that would be colored in, indicating that the 3 is included. So it doesn't just go up to the 3, but not the 3. It includes the 3. And you can have one of each. Infinity is not a number that can be included. Infinity is like a math idea or concept, okay? The idea that we can just keep getting things like bigger and bigger and bigger, or smaller and smaller and smaller. But it's not a number. You can't include infinity, because I'd say, okay, take infinity, add 1 to it. You know, it doesn't work that way. But the solution is really simple. You use an open interval. So the open interval just means, hey, this is not included. And since you can't include infinity, you'll use an open interval for infinity. Now, basically, we're just going to work through some examples. So I have here some number lines, and we have this interval right here, which is 2 to 4. And if you were to do this on using inequality notation, it would look something like this. 2 is less than or equal to x, okay, so we're trying to represent our x there, is less than 4, meaning that the value of the numbers in that interval, which we're just representing with an x, can start at 2, okay, and be equal to 2 because it's colored in, and it can be greater than 2. If you kind of read that inequality backwards, this would be x is greater than or equal to 2. So bigger than that, and then it would go up to the 4, but it doesn't include the 4. So that means it could be 3.9 or 3.99 or 3.99999, okay, but not the 4. Okay, and so we leave the 4 open, and we need to mark it as a boundary. In interval notation, that same interval would look like this. You would use the brackets to include the 2, And you would use a parenthesis on the other side to indicate that the 4 is not included, and that represents the interval from 2 to 4, not including the 4. And so what is good about this notation is it kind of removes the variable from it. So, when we're dealing with stuff like domain and range, we would have like an X for one of them for the domain and a Y for the range. And this allows us to just use one notation for everything. And it's a little bit, for those of you that don't like the inequality symbols, you can kind of avoid that. When you're using interval notation, you always go from left to right. So it's always the lesser number followed by the greater number. Always lesser to greater, lesser to greater. So if somebody were to show you this, okay, that would be wrong because it's going in the wrong order. So it's always the smaller number to the larger number. So you're always looking from left to right, okay? Now the next one here is the interval from -1 to 2, but neither the -1 nor the 2 are included. So in inequality notation, that would look something like this. -1 is less than X is less than 2, where you're not including the -1 or the 2. In interval notation, it would look like that. Now you might be asking yourself, well, that looks like the point -1, 2. Like this is the interval, okay, from -1 to 2. And then this could be the point -1, 2, which would be like right here, okay? So the coordinates -1, 2, and you might be wondering, how am I supposed to know the difference? They look exactly the same. Well, yes, they do. They actually do look exactly the same. So you've got your ordered pair, like indicating a location, and then you have this interval. The way you would tell the difference is context. So if it's a problem that involves plotting points, okay, then it's a point. If it's a problem that involves an interval, you're talking about increasing, decreasing, so forth, then like it's an interval. I've never, ever personally had a bit of confusion about it. So the same way that you know the difference between red and red, okay, when you're reading it, if somebody's saying out loud like, hey, I love that red sweater, nobody is confused about, what do you mean my red sweater, and I can't read a book, a sweater, like, I mean, it doesn't happen because the rest of the sentence puts the word into context. So the same thing will happen with this notation. Okay, so if you're a little like nervous about that, don't worry. All right, now what do we do if the interval goes off the end of the number line? So we don't actually have 2 endpoints. Well, if you have looked at my video on domain and range, then what you know is that this number line, this like arrow here, okay, indicating that it goes on forever, that goes all the way to -infinity. So this would mean that whatever the values are, they can just get infinitely small. In inequality notation, we would say X is less than or equal to 4, meaning anything less than 4, or it can go up and include the 4 as well, but there's no boundary on that. So we can go to -100, -1,000, -bajillion, trillion, gazillion, okay? It just keeps on going forever. In interval notation, it would look like this. So again, we're going from left to right, so we always do the smaller thing first. And in this case, the smaller thing is this -infinity. If you remember back to the beginning of the video, I said infinity is not a number that can be included. So you use the parenthesis for the open interval, saying, hey, I can't include -infinity, but that's where it goes. And it goes all the way up to the 4, and then it stops and it includes the 4. For this one, our interval is starting at the -3, and this time it's going off the greater than end, okay? And it does not include the -3 because we have the open circle. So using inequality notation, we would simply say X is greater than -3 because it's -3 and anything greater, but like, or any, like, you know what I mean, and not including the -3. If you are doing this with inequality notation, now you're going to invoke that positive infinity because we're going to the positive, and we are going to make sure we always do the smaller number first. So it's -3, not including it. So we'll use the parenthesis, and this time it goes up to infinity, again, also using the parenthesis. This is why, and again, if you've watched my video on domain and range, we kind of talked about domain of quadratics. When you are dealing with all real numbers, you actually use the interval notation -infinity to +infinity, and it's open because those are not numbers to be included, and it pretty much means the whole number line. Everything on the number line, like all of it. So that would be your interval notation for all real numbers. All right, so when do we use this notation? When do we see this notation come up? Typically when stating intervals using functions. So that would be your increasing and decreasing intervals, which if you've watched my video on traits of quadratics, it's a long video because it is the kind of thing that just needs more of a deep dive. But we, in that video, only used inequality notation, but you can use interval notation, and I would say my students are usually split about 50-50 in which they prefer. And you can also use this notation when stating domain and range. So those are your typical places where you will see it used. So we're going to look at this example, and this is going to embed a review of increasing, decreasing, positive and negative, domain and range. So if you have not studied that, so if your teacher is doing interval notation and you clicked on this video because you saw it was interval notation and now you're thinking, what is this? You are welcome to hang with me through the rest of this and maybe get a sneak peek into where it's going. But if I've already covered everything you needed to know, check out, just like the video, give it a thumbs up, let me know. Okay. And we'll see you in a future video. All right. So for everybody that's still with us, increasing. So our increasing is where the function is going up. And again, remember, we're going to use that x coordinate there. So it's increasing on that interval right there. So that means we are increasing all the way from -infinity, and we stop increasing at the -3. So this would be -infinity up to -3. Now, I typically will say it does not include the -3 because the -3 is like that very top point. So is it really increasing after that? I have seen math textbooks though where they do include it and they use a bracket there. So do whatever the convention and reasoning is for your classroom, what your teacher wants you to do. Now for decreasing, that would be where the function is heading down. And for that, again, we're doing this chunk of the number line, and we will invoke that positive infinity. And so it starts decreasing at the -3 and goes to positive infinity. One of the things I like about interval notation here is that you actually can see the whole number line. So if you were to look at this -infinity to -3, and we're just going to put them side by side, you can see, oh, we've got everything covered. It goes from -infinity to positive infinity. And just right here at the -3, that point is not included because it's not really going up or down there. So the interval notation makes that a little bit more visible that you've covered everything. All right, positive and negative. Positive and negative is where it's above or below. And so positive is this right here, okay? And that's going to be in between the -4 and the -2. So it's this chunk of the number line. And again, I don't include the +4 and the -2, or -2. And I don't even know why I said that, -4 and -2. I think because I'm doing a positive interval and I can't rewind that. So just, you're going to have to do -4 and a -2. And my sincerest apologies if what came out of my mouth was something different. All right. So we are not including either of those. So that would be -4 to -2. For my negative interval, that is the below, and that's going to be everything going out in either of these directions. And so using our interval notation, we're going to start at negative infinity and say, okay, it stops being negative at the -4. So that would be negative infinity up to -4, and then it resumes being negative at -2 and continues out to infinity. And what we do is we put a union symbol in there. Now, if that doesn't make sense, I did do a video on like sets and set operations, and union means it's, hey, it's both of these. Okay, so it's both this region over here and also that region over there, both together. So union those together, and that's where it's negative. So we use that union symbol. This is a quadratic. If you did not check out my video on domain and range of quadratics, please go ahead and check that out. The domain of every quadratic is all real numbers, so it is negative infinity to positive infinity. The range, however, is going to be a little different. So we're going to look at the range. It looks like we're topping out at a 1, and then we are going lower than that. So if I do the highlighting thing, okay, we do include that, and we're going lower, which on the y-axis, this is my negative infinity. So my range goes from negative infinity up to a 1, and it includes the 1. Okay, includes the 1. Now, a common mistake there, because when you're doing inequality notation for that, you would say y is less than or equal to 1. And there is a way that our brains process this where we want to say, hey, it starts at 1 and goes down. So I will see a lot of students do this, like 1 to negative infinity. And that is the right interval. Okay, so if I'm grading that as a teacher, I'll look at that and say, okay, the student knows what the range is, but it is an improper use of the notation because they got them in the wrong order. They started with something bigger and went to something smaller. So if you find that you're making that mistake, just incorporate like a little double check in it. And if you need to write it incorrectly first and then like look at it and say, do I need to switch the order of this? Do that and then erase or cross out the incorrect version of it. Okay, so this is the practice set. So a little bit shorter lesson, about 17 minutes. This is the practice set, and it is like a big review of increasing, decreasing, positive, negative, and the domain and range for each of the quadratics. Pause the video, work those problems out on your own on a piece of paper, figure out what your answers are, and then unpause the video, and we will go over those together. Okay, so here is the first one. I don't know why my words are so far over there. That's gonna make this not as great. Okay, so increasing. So that is going up from left to right. Okay, and so that is this piece, and it's increasing all the way until it gets to that 3. And so using our notation here, this is the negative infinity, and it's coming up all the way to the 3. So that is increasing from negative infinity to 3. I don't include the 3. Now, once you get some practice at this, if you're dealing with quadratics, you will say, okay, well, like it's got to be decreasing everywhere else. And so the decreasing is that piece, and that is your 3 all the way out to your positive infinity. And so we've got 3 to positive infinity. Now, positive is interesting. If you look at this one, this is never positive. So this parabola is never positive. Now, how you want to write that, you could write the word never. You could also use that symbol. That symbol is for the empty set. And again, you might want to check out my video on sets, okay, to see what that is. It just means that there's no set of numbers where this is positive, like it just never happens. And what it also means is that it's negative everywhere. Okay, so if you were to try to highlight where is this thing negative, you would end up doing something like this, where you're like, that's everywhere. That's all the way from negative infinity to positive infinity. And so that would be your negative interval. Your domain, if it's a quadratic, it is always all real numbers. And then our range here, okay, is -1 and downward. So -1 and downward, it does include the -1. And so remember, if you do have that tendency to get it out of order, so if you wrote this, you're like, oh, it's -1 and it goes down to negative infinity, just hold up, make a little correction. Okay, it's got to go in the other order. So that's going to start at negative infinity and stop when you get to the y value of -1. Now, for all of the rest of these, we are looking at x values. Range is the only one where you're looking at a y value. Okay, is the only one. Everything else is done with your x values. That's the only one that's going to be your y value. All right, next one. So for this one, increasing. So using my highlighter here, increasing means it's going up from left to right. So as I trace along there, and it looks like 4 is our spot where it starts increasing at the x is equal to 4, and it goes all the way out to infinity. And so this would be 4 to infinity. Decreasing is this piece over here, and that's going to continue going far out there, and that goes all the way to negative infinity. So it's decreasing from negative infinity and stops decreasing when x gets to 4. Positive and negative. All right. So positive and negative, the positive is this piece and also that piece. And so it's going to be that and that, like kind of the two outside pieces. And if you watch my video on key traits, do not try to memorize some bizarro pattern with this, okay? Don't say when the parabola looks like this, then my positive interval will take this form. Positive means it's above the x-axis. So highlight what's above the x-axis and then look at what intervals those are. So this first interval here, it's going to start at the negative infinity and stop when it gets to the 2. So this will be negative infinity to 2. This one over here starts when you get to the 6 and will go on for forever. So that'll be 6 to infinity. And then we use that union symbol to indicate, hey, it's both of these. There's these two regions where the function is positive, and there you go. For your negative, that's going to be everything in between the 2 and the 6. And again, what I like about interval notation is if you've done it correctly, whether it's the negative that has the nice simple one or the positive that has the nice simple one, it doesn't really matter. You should be able to see all of those real numbers. So negative infinity to 2, 2 to 6, 6 to infinity. And we just have the points at the 2 and the 6 that are left out because it's not positive or negative there. And if you compare that with your domain, which is negative infinity to positive infinity, what you're seeing is the entire domain is covered. It's covered with increasing and decreasing. So negative infinity to 4, 4 to infinity. There you go. And then here you can kind of see, like there's everything in the domain. Everything is covered. Now for my range. So for the range, it gets a little bit dicier. The smallest number it can be on the range is the -4, and then it goes upward from there. So this time we're actually going up towards positive infinity on that y-axis, and we're starting at the -4. So we start at -4, and then we go up to positive infinity. If you've made a mistake on this, it's not a huge deal. This is one of the more challenging things between the increasing, decreasing, positive, negative, and the new notation with the symbols. Give yourself some grace, okay? And just simply like cross something out or correct it in a different color. I always prefer that my students correct in a different color so that I can see, one, what kinds of mistakes they're making, because that helps me explain it better and teach. It also lets me know that students did the work and went and made the corrections and watched the whole video and did all of that, where if you just like erase everything, you just kind of erase the evidence that you did the assignment. So don't do that. Just go make some corrections. All right, last one, increasing. Okay, so increasing is this piece right there. Okay, and it increases all the way to the -2. So it's that like left-hand side. Sorry, that is so messy. I will erase it. And so we are starting at -infinity and we stop increasing when we get to the -2, which means the other half of this is my decreasing. So it starts decreasing at the -2 and goes on forever. So all the way to infinity. So -infinity or -2 to infinity. And again, notice the domain represented there. I'm going to jump down and do the domain. So the domain is -infinity to +infinity. And what you can see in the notation is you've got the whole domain covered. So it's either increasing or it's decreasing, except right at the tippy top where it's not doing either. Okay, so the -2 is the only piece that's left out there. But you can see -infinity, -2, and -2 to infinity. There it is. Same thing should happen with our positive and negative. We should be able to see all of it represented. So where this function is positive is right in between here. So it's positive in between the -5 and the +1. So there's -5 and +1, which means everywhere else it must be negative. So it's negative as we move off to the left and as we move off to the right. And so that means we're going to be starting at -infinity and stopping at the -5 where it becomes positive. And then we resume at the 1 and go out to infinity. And if you look at this, you can see again the domain. So -infinity to -5, then the positive takes over as we go from 5 to 1, and then it comes back and it's negative again from 1 to infinity. And there's your entire number line, except for the little endpoints that are not included because they're 0, which is neither positive nor negative. And last one is the range. So range, we are looking at the y's. So this one maxes out at y is equal to 9, and it goes less than, which means it is plummeting down to -infinity. You might be tempted to do this, okay? If you did, make the correction, okay? That has got to be switched. So you're going to start at -infinity and then stop at 9. It is a closed interval because the 9 is included. How do I know 9 is included? Well, if I plug in a -2 for my x, I get a 9 out. All right, so challenging lesson, challenging topics. If you thought it was easy, please give me a thumbs up and write something, because that means that I explained it in a way that made sense to you, which is always the goal. Please like and subscribe if you found this lesson helpful. Engage by dropping a comment, or if I left you confused about something, please ask a question. Check out the other videos on the channel, and we were able to get the lesson and the practice set done in less than 30 minutes. So I think that that is a win. I hope I see you in a future math video.